Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the binomial theorem for a positive integral index, the formula behind expanding any power or a binomial expression. Let's begin. The binomial theorem states that a plus b raised to the power n for any positive integer n expands as the sum from r equals 0 to r equals n and choose r times a to the power n minus r times b to the power r, where n choose r is the binomial coefficient n factorial divided by r factorial times n minus r factorial. This expansion contains exactly n plus 1 total terms, and the powers of a genuinely decrease steadily from n down to 0, while the powers of b correspondingly increase steadily from 0 up to n, with the sum of the two exponents in any single given term always adding up to exactly n throughout the entire expansion. The binomial coefficients themselves follow Pascal's triangle. Each specific coefficient equals the sum of the two coefficients genuinely directly above it in the row before, and they're symmetric. N choose r equals n choose n minus r, meaning the coefficients read identically both forwards and backwards. The general term or r plus 1th term, or the expansion is t r plus 1 equals n choose r times a to the power n minus r times b to the power r, and this specific formula is genuinely the single most powerful tool in this entire chapter, since it lets you find any one individual specific term, like the 5th term, or the term containing a particular specific power of some variable, without needing to actually expand the entire binomial expression term by term. To find a term containing a specific power of one variable, set up the general term formula, then solve directly for the specific value of r that makes the exponent on that particular variable match your target value, and substitute that r back in to get the actual complete term including its full coefficient. To find the middle term specifically, if n is even, there's exactly one genuine middle term, the n over 2 plus 1th term, but if n is odd there are instead two genuine middle terms, the n plus 1 over 2th and the n plus 3 over 2th terms. For any G binomial theorem problem, always start directly from the general term formula, t r plus 1 equals n choose r a to the power n minus r b to the power r, rather than trying to expand the entire binomial and then searching through it. This is dramatically faster and considerably less error-prone for these kinds of targeted questions. A frequently tested trap involves the actual numbering. Remember, the general term is t r plus 1, not tr. So if a problem specifically asks for the 7th term, you must correctly substitute r equals 6 into the formula, not r equals 7. This off by 1 indexing error is genuinely one of the single most common mistakes made throughout this entire topic. Also remember that when a or b themselves are negative, or contain additional variables and coefficients of their own, you must correctly expand the entire term to the power n minus r, and b to the power r, completely and carefully, including all of their own respective signs and coefficients, before actually simplifying the final answer. Let's recap. The binomial theorem expands a plus b to the power n as a sum of n plus 1 terms, using binomial coefficients from Pascal's triangle. The general term formula, tr plus 1 equals n choose r a to the power n minus r, b to the power r, lets you find any specific term directly, and correctly remembering that tr plus 1 not tr corresponds to the r plus 1th term, avoids the single most common indexing error in this entire topic. That's the binomial theorem for a positive integral index. Keep the general term formula and its off by 1 indexing sharp. They unlock every specific term question in this chapter. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.